AP Stats, this is our review for today. Just heads up, we're on Check Your Understanding 7.2. And we're about ready to go over it here in a second. Y'all have 3 minutes left. 3 minutes left. Or 2 minutes left, my fault. 2 minutes left. Just get down as much as you possibly can.
I'm pressed. Oh no. Okay, what's P?
Oh, this right here, the applet that's online when you watch the video. I pull up an applet, it's actually a QR code. You just scan it, and when it pulls it up, you just kind of, it does it randomly for you. And it randomly tells me how many Reese's were orange. And it says it's randomly this many. This right here, if you want to take a picture of this as you leave, this was the number of oranges from my class. And this was the proportion of those. So we just talked over like that idea. Cool.
We don't.
Go ahead through just number 4 because I didn't put number 5 on there. But if you did, that's perfect. You could pretty much that. Well, only you could put 5 down because I think you know that. But you know, as far as this, it's only 1 through 4 was up here. We'll keep it as this.
Do you have an extra table A by its
I think one's right behind me. Right above Jacqueline on the top. I usually keep some up there. All right, hey, look up here. Hey, pencils are down for right now. Normally I'm not as stringent, but because we're giving away something that I don't normally do. In fact, I don't know if I've ever done this. So that's okay. All right, but I do want us to at least treat it like some sort of test where we have some integrity on that. All right. So do this. Just double check. I've kind of come around and checked to see where you're at. Give yourself a point for every one that you come to. If you got to number 4 and got that one right, give yourself 2 points on that. I'll tell you what, we started off with a bang on this first question, right? It's a pretty tough question. Let's talk about just this concept real quick. The first thing, this idea of the mu of p hat, which is our mean of our sampling distribution of p hats, right? Where every dot over here, we talked about this, every dot is a p hat, right? Is a sample proportion. That mean was 0.75, right? And really the formula states that it's equal to p. If you got that right, give yourself 1 point, all right? Technically, on the test, write the formula first, then write 0.75, right? I didn't really even do that, so shame on coach. But make sure it's equal to that 0.75. How many of you got that one right? Money. Okay, cool. Number 2, the standard deviation of p hat states that and I'll put it up here, the standard deviation of p hat is equal to the square root of p times 1 minus p divided by n. Okay? That makes sense? And I plug it in, 0.75 is our p, and 1,000 is our sample size. And when we plugged it in, we got 0.014 as our standard deviation. Okay? Give yourself a half a point if you got that correct. You say, Coach, why a half a point? Because then it also said, well, really kind of 2 things alongside that, which I didn't put here. First of all, we'll do this. If you did this and then said the proportion of young adults who watch online videos in the sample typically varies by 0.14 from 0.75, which is my true proportion, then you got the other half for interpreting it, okay? So again, you would get half for doing this and then half for doing the interpretation because it did state that in the problem, okay? Also, I will give you a full point if you also check the 10% condition, okay? So this was kind of a side one, but if you check the 10% condition, which states that little n is less than or equal to 1/10 of big N, and you plugged in 1,000 for little n, what would big N be?
It's unknown.
All young
Yeah, it's all, right, all internet users, young adults from 18 to 29. So would that be bigger?
Yes.
Absolutely. So it actually still would be okay. So you would plug that in.
So plus 2. If we wrote it out and just said 10% conditions met due to the massive population.
That's awesome. Yep. That's probably better than even the formula, but I'll take either.
So you get an extra point if you do that?
Yep, you'll do this. You got one right here, one for, or half for each part of this, and then one for up here. Okay? Now, here's one thing, just kind of keep a mental note. In order to use this standard deviation formula here, I have to check the 10% condition. Okay? There's stuff with that, but it's got to either be independent or I check that 10% condition in order to use the standard deviation formula. Okay? But what's nice is on the actual FRQ on the test, I actually break it up like this. Okay? Which is kind of nice. I just say, okay, what's this and this? So highlight and come back to this. Number 3 says, can we approximate this as normal? And within this condition, remember it's n times p is greater than or equal to 10, and n times 1 minus p, if that's greater than or equal to 10, then by the law of large counts, we can state that yes, it is approximately normal. If you did that, give yourself a point.
Wait, what is the equation
Well, we didn't.
for the 10%?
We wrote the equation.
10% conditions up here. I don't know if you could see it, Brianna, but little n is less than or equal to 1/10 of big N. So little n is less than or equal to 1/10 of big N. Big N's my population, right? And you notice we don't know my population, but population's all of those ages 18 to 29.
So what?
Say that again?
It would.
It would, yes ma'am. So yeah, you're good to go on that. Okay? And just so you would just either write it out or just say it's much larger and therefore we can go ahead with this. Okay. All right, number 4, notice since we can approximate this as normal, we use the mean and standard deviation from 1 and 2, just like you would with a normal CDF. We put the 0.75 right there in the middle, but then it says, what is the probability that we'll get a result within 2 percentage points of the true value, which means we're really going 2% either side. So that means if this is the mean, we could either go from 0.73 to 0.77, okay? And anything that's shaded in between is the probability or area of that actually occurring if we took a random sample of 1,000 young adults. So you could either use z-score here, or you could use normal CDF, lower bound, upper bound, mean, standard deviation. Just remember, this is a big thing. Go back in the notes and in the podcast. This idea of the z-score equaling p hat minus p divided by the standard deviation formula, be familiar with that. That looks complicated, but you've done it before. It's just in a different context on this one here. Okay? Why did I have to get 2 z-scores?
Because with a range of 2%.
Exactly, range of 2%. It's not just less than, right? That's good stuff, Alex. Good work. So this would be the area that we would find either through normal CDF or through our z-score stuff there. Okay? Anybody get that one right?
If we have more time,
We got.
Yeah. Took maybe a minute.
Do we have to draw it and list that 2 circle thing on the left?
Did you get this?
Yes.
You got this? You just forgot to draw it out?
No.
I would say on the test you got to draw it out. If you got the answer without drawing it out and really showing them the other work, give you 1 out of 2. Yeah. Okay? You could have gone to number 5, which just, I'm not going to count number 5 just because it wasn't on the previous slide. But as we increase the sample size, what would we expect about our standard deviation? What would happen to this number? That number would decrease, right? Our variability would decrease. Cool, cool? All right, we're going to go through some other questions here. So hang in there. We're going to do these a little bit quicker on this side. Okay? My apology. That was me in high school. I don't know what. I don't know where I found that. I was going through it, and I was like, who is that? I was like, that's me. I was weird in high school.
Wait,
That was me in high school, yes. I don't know what I was doing, yes. Do not know.
First of all, that's definitely.
All right, here we go.
Actually,
That was actually me. Yes.
you gotta be
No, wait, do you not think so?
It does not look like you.
That's me.
lying.
I have sunglasses.
Yeah, you see, baseball was my thing, so I've got, yeah.
Pretty good.
That's pretty good.
Those balance bracelets they always used to like.
Yes, the balance bracelets were like the thing. Yeah.
Cody, how old are you?
Some things don't. How old do you think I am?
I know you're like early 20s, aren't you?
You're 30.
I think I'm 27.
Like mid-20s. Right?
I'm 28.
Oh.
28.
You are?
Yeah.
That's so young.
Yeah, you're young. You were like,
You're so young.
You think I'm old?
no, I didn't think you
Here
were
goes
old. You're
Jamie
just
again.
not having a baby. But I can see.
All right, here we go. Next question. Hey, we're gonna do this. Each of the parts in the yellow will be 1 point each. So write these out. You gotta write them out. These are straight from. By the way, I don't want you to think I'm making this up. This is the concept list. Got me? Very important. So I'm pulling off this. Question 1. What is a statistic and what is a parameter? I don't need a huge definition. Give me a quick definition, real quick. So we're not gonna answer. Just write them out real quick on that. Okay?
I'm sorry.
Write them real quick. 1 point. What is a statistic and what is a parameter?
Oh, this is for the point thing again?
Yep, for the points, we accumulate them. Keep
Sorry.
track of those. Question 2, once you're done with that, I'm giving you about a minute each to write these out. The next thing, write 3 variables that describe a statistic and 3 that describe a parameter. Got me? And then tell me what estimates the other. So what in a statistic parameter, what estimates the other, and then the other question above it, just like I said, 3 variables for each category, for statistic and for parameter. At this point, let's put notes away just for the sake of what we're doing. So we're going to try to do this through memory now.
Can
Okay?
I write on the back of my notes?
You can, absolutely. You can use any formula sheet that you want to, though. That's appropriate for today. From here on out. I think it'll go back into 7.2 a little bit, but just a little more. Well, because when we get by, I'll show this to you. When you go from 9,000 to 1,000 in this case, it's going to decrease the variability, and I'll show you through the formula on how it actually ends up.
You got something to say?
And on the
Should we
bottom,
talk?
What were the other
Is that
questions?
it? Or you just write that?
Right, 3 variables.
correct, just take it straight with the knives, right?
No, she won't help you.
Yeah, I can show you that. I found an area of this. All right, here we go. Let's get it.
Michelle, what are the other 2 questions?
These 2 right here. These 2 right here. So this is 1 and then this is 1. Okay? All right, here we go. Eyes up here.
Wait.
Pens and pencils are down.
Okay.
All right, question 1. As we do this again, you cannot add to this, and I've been kind of coming around. Just be honest. If you got it right, great. Give yourself a point. If you got it wrong, that's okay. We're learning. Statistic. What is a statistic when we talk about a sample? Ronnie.
Number representing my sample.
Good. You have to say a number, and it has to describe what? Our sample, right? If you say it is the sample, that's not true. Okay? It's not true. Chloe?
Say like a proportion representing the sample.
What'd you say for parameter?
A proportion representing the population.
Okay, so this is a number. I'm going to answer that in a second. A number representing a population. a number describing a sample. Okay? So those are both true. Chloe, I'm going to give you all 1/2 because a proportion is part of it, but that's not the full thing. Does that make sense? And that kind of answers this second part here in a second. All right?
Are these half points or 2 points?
So this would be 1 full point here if you got this one in yellow right. Okay? Now the one in white is half of each because it's kind of a two-parter. On this one it says write 3 variables for each category. So we've got sample and we've got population. Okay? All right, what are the variables for sample?
Explore.
Yes? P hat and
SOS.
S of x, right? Standard deviation. What about for population or for a parameter?
Mu.
P mu
Standard deviation.
standard deviation. Excellent. Okay? If you got that, give yourself a 1/2 point.
What if we got 2 out of 3?
Let's see if you got this bottom one here. Cool. What'd you do with the estimate?
Statistics estimate parameter.
Perfect. If you said that, then we'll give yourself a 1/2 point on that. A statistic estimates a parameter. So these all estimate to the parameter side, right? Okay, so these statistics estimate a parameter. You gotta state that, okay? If you got that, give yourself a 1/2 point, and we'll rock and roll. Next question. John Mike, we got some?
On the formula sheet, it has the standard deviation symbol with a subscript of p hat. Is that the same thing as S of x? Or?
That's a good question. We're gonna get to that question here.
Okay.
Cool? It's part of a sampling distribution. And that's a really good question. All right, here we go. What is a sampling distribution? Write that out. And then tell me really quick what this top yellow dot means if it's over, and I know it's not, but if it's over 0.4. In terms of our Reese's, if you remember those that are orange, tell me what a sampling distribution is, just quick definition, and then tell me what that one yellow dot means. Go. It's this one at the top, Chloe. It's basically, yes ma'am. I'm going to say it's over 0.4. I know it's not, we'll just round it up there. So it's 0.4. That one yellow dot's over the 0.4 of 40% of orange Reese's. What does that one specific dot mean in the context of this? Cool. That would be all adults.
What do I write for like the sake if I use like the 10%?
Yeah, you would just say, I literally put in there all adults, all U.S. adults. And then literally I say it's going to be much bigger. 1/10 of all U.S. adults is going to be much bigger than 1,000. What's that? You think that was older?
And the neighborhood are friends.
Really?
Yeah, you seem more like sophisticated.
I don't know about that.
Beautiful family and everything.
Yeah, so you say like the yellow dot.
We did.
Yeah.
Almost same neighborhood. Almost.
Almost, yeah.
Where?
No, and what's not like where
All right, here we go. Eyes up here. Let's roll. Sampling distribution. You needed to write that it was a sample of a sample. Cool. Needed to write that out of some kind. Now, this dot right up here, could someone describe what this one dot means? I'm going to be picky on this one. Either one. Yeah. Sarah, go ahead.
Oh, if it's a sampling distribution, it's like one specific instance in which the mean of the sample was 0.4.
And yeah, I would just, because this was also, I would give that to you today because I know it was harder to see. I would say for our p hat value, this would be one instance, right? One sample of size n, whatever our n was. We did 50. If you said 50, that's perfect. Of size n, that would have a proportion in that sample of 0.4 oranges that was there. Does that make sense? If you said mean, we're not there. You're not old enough yet. We are not talking about sampling distributions related to means on this test. Only proportions, okay? So it's important. Don't go to 7.3. You'll confuse yourself. Just 7.2. So sampling distributions that we've talked about, we've only used p hat, which is just proportions, right? The dot right there, I would say that one dot represents one sample of size n that in this case has a p hat value of 0.4, right? Which means that that sample proportion is 0.4. And then context, a little context at the end, a little spice it up. Cool. All right, good stuff. If you did both of those, give yourself a point. If you got half of one right, maybe you got one of them right, give yourself a half.
Is it 1 point per?
Half a point per.
Oh.
Half a point per. Okay? All right, let's check scores just to make sure we're all Gucci here. All right, Alex, where are y'all at?
We are at 6.5.
6.5. Who's got more than 6.5 right now?
Hold on.
We have start counting.
7? Y'all have 7?
We don't have an ours.
Calculate
We have
yours real quick,
7.5.
just so we're. Y'all have 7.5? Okay.
I know.
5?
We're going behind a little bit.
Cool. Just at some point on the next question, total them up so no one's like knocked off guard there. Okay, so you have an idea of where we're at. Next one. All right, here we go. Each one of these are 1 point apiece. This is not on your review sheet. This is just extra. So it's a good one, maybe just to get down. Again, this is podcasting, so you can go back and check it out. Go ahead and just put the answer. So it'll be A through D, or A through E for all three of them here. And by the way, that arrow represents the true population parameter.
Where is this?
This is not on your sheet. This was a little bit of an extra that I added late in the game. Do you need me to blow it up a little more? Yeah. Hold on just a second, y'all. My fault. We'll do this first, and then I will bring this one back, okay? Cool? Do these first two. Do the first two, and then I'll bring the third one in. We'll do the first two first, and then come back with the third. Is that better, Brianna?
Crochet, how exactly?
Everybody knows that.
Like,
Everybody knows.
like they look very similar, but have slightly different colors.
To the ear seat.
Like during the summer, I basically stopped.
But they go out once they fart.
But like,
I don't
it's
know.
unnecessary.
Yeah.
I limit myself. Like, I don't take it out of my colors.
Yeah.
One time is when I'm driving.
I see what you're saying. Huh?
Boy.
I see what you're saying. That could be a little deceiving. This is similar. If it's like it's definitely this, then maybe I would do more.
It's like 20 minutes of
All right, y'all good with number 1?
Yeah.
All right, here's number 3. If you're still working on 2, it'll be below it. But this one up here is number 3.
I hate
school, every single class. Fully empty. Sometimes during.
Again, for each of these will be 1 point each. 1 point each there.
And it gets to a point where it's just like, there's no point. The statistics that have less variability among these 3 is.
Cool. We got about 10 minutes left, so we're gonna keep going through some questions here in just a bit. Okay. Is it intense? Is this the most intense review game you've ever been a part of?
Because there's so much writing up.
It's true.
We need a nice.
My dad used to be a teacher and give away free 100 on a review game all the time.
Oh my gosh.
I remember that.
You should get to the top like 3 teams.
I'm not done, Christian.
Oh, my fault. This one?
Yes. Is there a number 4 or is that it?
Okay, was there 2 questions or 4?
Just 3.
Okay.
Just 3. So the one is behind the one that's on top there. Does that make sense? And the other 2 are in blue.
Just like the top one.
You good right there? We're good? Okay. Hey, let's check it out. Let's make sure and see where we are at, all right? So number 1, the statistic that has the largest bias among these 3 answers should be locked in. The answer for number 1 would be?
C.
The largest bias would be C.
Yeah.
Whose center would be furthest away from that arrow of the true perimeter? It'd be the bottom one. The center for this one would be about there, and same thing here. Okay? So the smallest bias, right? We can talk about that later on. But the largest bias is the one that would have the center not on the true parameter. Does that make sense? This center would be like over here. Number 2, the statistic that has the lowest variability among these 3, definitely not A, right? I would say that with B and C, those are pretty doggone similar. Okay, they have a pretty similar range, pretty similar deviation. So I would say that B and C, which is answer E, would be the one that would be the correct answer.
Wait, what?
Okay.
Which?
Say that again. The answer would be E,
E?
because both of these have similar spread, have similar deviations from the mean. Okay. Yes, John Michael.
I mean, but C is noticeably larger than
B.
B.
That's how I was saying.
Like B is equal on both sides, but C, you can see the differences on both sides.
I feel like B is noticeably, the variability is noticeably lower.
I would say, okay, so just in checking this, right? I would say that, and I think the key word, and this is a tough one, I think, similar bias, you know what I'm saying? If it said this was highest, yeah, I could see that. Right here, you'll notice that these 2 are actually the same, right? The next one, this one's 1 higher. But then what happens is as we go to the right, you'll notice that it just exchanges from columns 3 and 4. Does that make sense? And so, yeah, I would say that there's definitely going to be one that's higher or lower, but the actual deviation, the standard deviation or the spread, the variability of the data is fairly similar, right? I'm not going to say it's exact because you're right. It's not going to be exact there, but I would say that the best answer would be, and this is the one thing on an AP exam that can be tough, is that E would probably, or would be the best answer that's there. John Michael, I hear what you're saying though. I do see that. Do y'all see that?
So half a point.
If you put the, did y'all say B? If you put B, I'll give you a half a point there because I could legitimately see that. But the best answer would be E there. Jaden?
Christian, number 1.
Oh, my fault.
Number 1, we kind of like just took a guess at it, but I still don't understand. I don't get why it's A.
Or why it's C? This is the true parameter, the arrow, because that's what it said in the problem. Where's the center of this distribution? Right here, right?
Yeah.
Where's the center of this distribution? Here, right? Where's the center of this distribution? Here. So if it falls close to this arrow, what that means is that if we're talking about mu or x bar, we're saying mu and x bar are tight, right? Are equal. In fact, that's unbiased when they're equal. But the further away they are, the higher the bias.
Okay.
Am I making sense on that?
Yeah.
Good stuff. Did I just mess that up? Sorry. All right, cool. Number 3, based on the performance of the 3, which would be the best? We want one with low bias and low variability, right? Which the best answer would be B. Yep. Letter B. Good stuff. If you got all 3 of those, give yourself 3 points. Unless obviously you got partial credit on that one, you can give yourself a half there to get 2.5. If you got the other 2 correct. All right, next question. Here we go. Oh, we're gonna skip this one. Skip this one. Let's go here. Tell me numbers 1, 2, 3, and 4. Okay. This will be 1 point. This will be 1 point. Number 1 and 2. What is the law of large counts and what is it used for? So give me the formula and just tell me what do I use it for. The law of large counts. Tell it to me. And then what is it used for? I will give you an extra point. Don't yell it out. If you could also tell me for an additional point what another name for numbers 1 and 2 is. And then the same thing for 3 and 4. What is the 10% condition? And what is it used for?
It's written in my notes.
This one's tough. This is also not on your formula sheet, so you can't look at your formula sheet for this one.
Oh my god.
Use 10%.
The one that you were talking about yesterday, like.
There's two of the two kind of weird formulas that show us something. One's 10% condition, one is law of large counts.
Sorry. I was like in between.
You do that, Sean?
It's a lot.
Sean?
So,
Again, total up your points there. Well, this will be our last one.
Yes, that is 10%.
10% condition.
Large count.
You'll have about a minute left to finish that out. I just want something quick. Just the formula, and then tell me just real quick, what is it used for? Nothing really elaborate.
We knew the formulas, right? Oh, we did that.
Say that again.
No, we're
Oh.
just.
Yeah, these ones are not on your formula sheet normally, so just a heads up on that. All right, are we ready? No, still writing? All right, hey, do this. Chill for me for just a second because I want to finish this up real fast. It will go real fast here. Law of large counts, in order to get the formula, you needed to say n times p was greater than or equal to 10, and n times 1 minus p was greater than or equal to 10. The reason for this is to approximate something as normal. Okay? All right, additionally, another name for that is the central limit theorem. If you got all that, that's 2 points, so add it to your score. The one below the 10% condition states little n is less than or equal to 1/10 of big N.
Got that, okay.
All right?
What's it used
This
for?
allows me to overcome something that has no independence. So whether it has independence or not, it doesn't matter. This allows me to overcome independence, or you could have said that allows me to use my standard deviation formula. If you said that, I'll give that to you as well. Okay?
so wait, that's 3 or
1
4?
by 1.
So this is 1 point, and then 1 for an additional, so you can get a total of 3 if you got all of those correct. Total up your points for me.
What if I just got the formula? 10%?
That's half. So each of those would be a half.
Yeah.
That makes sense?
So this whole thing is worth 2 points?
So yeah, this would be 1. This would be 1. This would be 1.
Oh, we lost.
Wait, we got
So if you get 1 and 2
Is there-
correct, that should be
That'd be 1 point.
we got 12.
Oh no, we got 12 too.
So we
You got 12.
Don't do that
You got
to us.
12?
No, on God. I just.
Don't do that.
I-
Rock, paper, scissors.
On God, I
I
got
think
I
we
turned
both
it
have to
over.
get it. Rock, paper,
Well, dude, it really
scissors.
doesn't matter. We got 5.
I don't know.
Here's our scorecard.
Well, we weren't here yesterday, so we
Okay,
couldn't.
let
It's turning in our scorecard. I got 3.
Yeah, you can look at my work. I have the work.
So this is yours too.
Yeah.
Your scorecard.
This is-
But that's okay.
I didn't know we had to do a scorecard.
Rock, paper, scissors. No. Could have done. Yeah. Sudden death. 1 out of 1. Give me $46.
Perfect. And you said y'all got it too?
Oh yes.
Y'all got it too on that? Okay, do this.
Why
Come
use
over
your
here so we
notepad?
can just talk through
Use your note.
what that will look like. Thank you very much. Appreciate
Yeah,
it.
Michael, where's your work?
I just said I used this. Put his name on it.
Alright, with y'all 4 being, since there's 4 people, okay, I think what we're gonna do is this. I know we said a 90. What I'm gonna do is since there's 4,
You said 95.
I said 95.
I did hear 100 also.
Here's the thing. I need you to do me a favor, just because we're 4 people in. I need y'all to make sure you obviously complete the review, right? Because I need those reps in, and then I need y'all to attack the test the best you can. Does that make sense? Because you can obviously get a higher score, and with this test, I think we could. To be honest, I think we could get a better score than maybe what we've had in the past. Yes. But not yet. We'll do that later on. So cool. That makes sense. But here's my big thing, and I think this is a good caveat for you. You gotta at least have the review done. Say that again.
You said everyone else got extra points.
Did I say extra points? I did not mean to say extra
You
points.
said
I heard him.
I just said it was optional.
Yeah, you said it was optional, but if you did it, you would get extra points. Can I get that to replace one of my homework grades?
Yes, that.
You do that. Yeah, I'm handing out grades like crazy. No, it's all good. Is that cool? Is that cool on that? There are some things on the review that you don't need to know, so just check the end of the podcast out for that. Okay? Sound good? Alright, right on. See y'all. You're welcome. See y'all.
Even when you don't give us points.
Yes, I will.
If I don't leave this place immediately, I hope.